Let's look at another example of the electrolysis of a molten electrolyte. Let's look at the electrolysis of molten lead bromide. Okay, so similar situation to what we were dealing with last time. And what you're going to find is that when you're dealing with molten electrolytes, the substance is usually binary ionic compound. What do we mean by binary? It's only made up of two elements. So the previous example was copper 2 chloride. It was only made up of copper and chlorine. In this example, lead 2 bromide is only made up of lead and bromine, nothing else. So no sulfate, no nitrate, nothing like that. Those types of compounds would fall under the electrolysis of aqueous electrolytes. And that's something that we will look at afterwards. So we're going to set up our electrolytic circuit. So we have our electrodes, our graphite electrodes. We have our power source. For those of you that don't know, the longer stick indicates that it is positive. That's a positive terminal. And the short stick indicates that that's the negative terminal. Okay? We have our electrolyte, which is going to be the molten lead bromide. And in order to keep that ionic compound in a molten state, we have to apply heat. So this electrode that's connected to the positive terminal of the battery is the positive electrode, and that's going to be our anode. And this electrode that's connected to the negative terminal of the battery, that's going to be our negative electrode or our cathode. Okay? Now, in our electrolyte, we're going to have our lead ions and we're going to have our bromide ions. The negative ions, the anions, are going to move to the anode, and the positive ions, the cations, they're going to move to our cathode. So remember, first question you can be asked, what substance is discharged at each electrode? So at the cathode, at our cathode, Pb2 plus ions discharged. Remember, what happens when an ion gets discharged is that it loses its charge. If the ion is positive, it's going to lose its charge by gaining electrons. And if the ion is negative, it's going to lose its charge by losing electrons. So we know that our lead ions are being discharged. So if they ask us to write what the half equation is, we're going to have our lead ions, Pb2 plus ions. In order to get rid of that 2 plus charge, we need 2 electrons. So the pluses with the minuses will cancel out. And then we're just going to have Pb. Now you know that lead is normally a solid, but because this thing is being heated, the lead that we form is going to be a liquid. Okay? So that's our half equation. What redox process is taking place at that electrode? Now at our cathode, our lead ions are gaining electrons, and oil rig oxidation is loss, reduction is gain. So at the cathode, electrons are being gained So reduction is occurring. Okay? Now, because we're forming a solid, at the cathode, what we are likely to observe is that a solid is going to form around the electrode, then it's going to melt and drip off and fall to the bottom of the crucible or the bottom of the container. Okay? So that's what's happening at the cathode. Now let's take a look at what's happening at the anode. What's happening at the other electrode. So at the anode, Br minus ions are being discharged. In a situation where you have a molten electrolyte, there are only two ions, one cation, one anion. So it's very straightforward. But when we look at aqueous electrolytes, there's going to be two cations and two anions, and then you will see the importance of why I highlight what ion is discharged at each electrode. Then we may be asked to write what the half equation is. Remember, half equations show the transfer of electrons. So in order for this Br minus ion to become discharged, what has to happen is that Br minus has to lose an electron to form Br. But Br is diatomic, so you need two Br atoms to combine to form Br2. Bromine is usually a liquid, but because of the heat, it causes that liquid to evaporate and form a gas. Okay? Now, just like in the previous example, we can merge these two equations together and we can just say that two Br minus ions lose two electrons to form Br2 in the gaseous state. All right. Now, because we are losing electrons, what redox process is occurring? Oxidation, because electrons are being lost. Okay, so just like before, at one electrode you have reduction taking place, at the other electrode you have oxidation taking place. Now, here, bromine is a reddish brownish orangish kind of liquid, and because the heat is present, that liquid will come off as a gas. So what are we going to see? Whenever we have a gas forming, we're going to see effervescence of a reddish brown gas around the electrode. Okay? So those are the main questions, the main types of questions that you can get asked in a redox scenario, in an electrolysis question, specifically electrolysis of a molten electrolyte. You can get asked what ions are discharged at what electrode. You can get asked what redox process is occurring at each electrode. You can get asked to write the half equation and you can get asked what would you observe at a given electrode. Okay, so those are the main things that you can get asked. Not saying that these are the only things, but these are the main things. These are the most common things that they can ask you when you're dealing with electrolysis of molten electrolytes. Electrolysis of aqueous electrolytes is slightly different. It's a little bit more involved, but it's the same principle and it's pretty easy.